My name is Tom Scherber. I'm a project manager with the University of Minnesota Building America research team. We're standing in front of a home in North Minneapolis, and we have had the opportunity to install researched measures that will make this house perform much better. One of the measures is a roof overcoat, we call it. It's applying the insulation and waterproofing on the outside of the roof rather than from the inside of the house, and that helps completely eliminate ice dams. The membrane is a 60 mil thick waterproof rubberized membrane. When you run screws through it, it heals around those screws, so no water can get through that membrane even after you've drilled screws through. It needs a clean surface to adhere to. So what we do is remove the shingles, removing any loose nails or pounding them down, and repair any damaged roof decking. In this case, we found that the outer edge of the slope part of the roof was very uneven, had some sharp edges. We were concerned that the rubber could be poked through. So we just got some metal angle iron and put it up there. Part of the roof prep is to tie the sloped part of the roof to the vertical wall below.
We have to rip up the overhang of the roof so that when we wrap the membrane over, it can run down flush to the sheathing on the wall. When you're cutting off the roof line flush with the wall, it's better to be too deep than to hang over even half an inch. So what we're going to do now is go back and get it to plane perfectly with the wall sheathing. I hit the rafter there and it bumps out just a little bit, so I need to give a little more attention to that. So now we're good. The rafter tail is not protruding. The roof line is cut back with just about exactly 1/8 of an inch clearance against the wall line. So this spot here is completely ready.
In order to make this thing really stick well, it requires a bonding agent or primer. And we roll the primer on with a paint roller and give it about 45 minutes to get tacky. And then when you touch the rubber to that primer, it does not let go. It's a very permanent adhesion. The bottom edge of our membrane must overlap the very next protective layer on the wall. And in this case, it was tar paper. We run the bottom edges first, then we go up the sides of the slope part of the roof, which is called the gable ends, and then we do the valleys. Now you've got all the edges covered, and then you fill in the inside when we start from the peak and run it all the way down to the edge. So once we got the entire roof covered with the membrane, we now have an air barrier, vapor barrier, and water barrier all in one element. And we're ready for the next step, which is insulation. We use 2 layers of rigid foam polyisocyanurate, one 3-inch and one 2-inch, to get a total of 5. We wanted to have a consistent bottom edge, and so we beveled it to correspond with the angle of the roof. We put 2x4 stoppers so that we knew where our starting point was, all the way across the bottom edge of the roof. The reason we use 2 separate layers is we want to offset the seams so you don't have a 5-inch seam that's letting air go all the way through. Every seam is covered by the above layer. The second thing we do with the seams, we use canned foam to foam each place where 2 pieces of foam touch, both vertically and horizontally. After we put up the first couple of courses of insulation, then we started at the bottom with our furring strips. The furring strips are 2x4s which lay on top of the insulation and are very critical to the structure of the new roof system. They are adhered with a 10-inch screw that go all the way through the insulation, the 2x4, into the rafters. And then the OSB sheathing for the new roof deck can be applied on top of the 2x4s. Between the 2x4s is an 1.5 inch space that will actually ventilate the roof. That ventilation is critical for preventing ice dams. In the wintertime, the ventilation cavities keep the roof deck cold so that no heat gets in there to melt the snow, which causes ice dams. Furring strips have to move air straight from the soffit all the way to the peak. So they're straight up. It's a pretty easy thing to do. But when we get to the valley interrupts those furring strips. So we have to create an air gap every 3 feet so that air can move sideways, and essentially work its way out of the valley area of the house. The 10-inch screw is critical to the structure of the new roof.
We're using 10-inch long GRK screws that will be going all the way through the wood, through the insulation, and then it's very important that we hit the actual roof truss. If you hit the truss, it'll keep on pulling down, and then you can countersink the screw into the 2x4, and you'll know if you miss. See that miss? See how it pulled up? There will be some misses, and that's okay. The important thing is to know that you don't pull the screw when you do miss.
Remember that the membrane is self-healing, as it's already healed around the screw. You just drill another screw and continue on the way up. Now that we have the furring strips firmly in place, we can apply the new roof deck using 1/2-inch OSB. And then from here on out, it's like a regular shingle system. You put tar paper, and the shinglers put their shingles, and then a ridge vent cap at the top. In order to complete the ventilation that goes out the peak of the roof, we have to create an intake at the top of the wall. We continue the furring strip that stops at the bottom edge of the roof down the wall 14 inches. That creates an opening at the bottom of the 2x4s so that air can come up and go all the way up to the peak of the roof. Then to protect the bottom edge from insects and rodents, we put a screen on the bottom edge. We designed a simple trim package. We didn't want a full flat surface. It just doesn't look right architecturally. So we stepped it out with three pieces of wood. Now that we have the roof overcoat completed, the side walls or the gable end walls needed to be insulated and air sealed. Because the owner chose to keep the existing siding, we couldn't do the insulation on the outside, so we did it on the inside with spray foam between the studs. And carefully seal the roof wall connection at the edges. What we have accomplished then is we've completely sealed the upper level with insulation, and we stopped the air from rising and leaving the house, making it much more energy efficient and much more airtight.